So welcome. This is reduced downtime with the Progress Application Server for OpenEdge HealthScanner. My name is David Clary. I've been with Progress 25 years. I started originally on the WebSpeed 2 release and been part of the team that created Classic App Server, all the adapters related to Classic App Server, and PaaS for OpenEdge. I'm currently the PaaS for OpenEdge product owner. So how many people here are currently using PaaS OE, at least in development? Good. And how many people are playing with it in 12.0 at this point? Okay. So this feature is a 12.0 only feature, ships with 12.0. And we'd like to get some feedback on what you guys think of it when you start using it. So what is the Health Scanner, and why do I want to use one? That's the big question. Next will be how our Health Scanner works. And then finally, we'll take a little look at the Health Scanner in action. So what is the Health Scanner and why do I want one? So our primary use case for this is, as a DevOps, I want to efficiently check the health of my server VM to decide if it needs to be taken out of service and replaced before my users are impacted. This feature is geared toward running in the cloud with multiple VMs, where the VMs itself running the application server aren't the important piece. The important piece is your database, which is running on a different system. And these VMs are basically runtime engines that if they start flaking out, you just want to replace them. So your users have the most minimal impact. So what it really is, it's like the check engine light in your car. Normally you're driving around, you see this check engine light on, you know something's wrong. It's not going to blow up, you don't have to pull over and call a tow truck, but you probably do have to take it in for an expensive bill at the auto mechanic. So obviously, a lot of people just ignore these check engine lights, and you do so at your own risk. Eventually, it might be nothing, might be your gas cap is loose. I've had that happen before. But it could be something more serious that'll lead to problems down the road. So when we created the Health Scanner, these were the requirements that we laid out. We wanted to provide an overall score of the VM that reflects the server. This includes OS metrics and resources, Tomcat resources, OpenEdge resources and metrics. All of this stuff is built on JMX. When we created PaaS for OpenEdge, we created a rich JMX interface of everything going on our side. Tomcat and Java provide their own JMX beans to tell what's going on in them. And the Health Scanner basically uses this information in order to do its job. We wanted it to run efficiently in the background without affecting applications. So it's deployed as its own service on the PaaS OE server. It doesn't use any resources towards your application. It has its own executor threads, its own port, and if it's turned off, then it uses absolutely no resources at all. Provide an answer immediately. When you do ping the health service to check the health of the server, we don't go and then pull all our probes and return the health in real time. We have two parts of this, and we'll get into how it works in a little bit, but we have a collector, and then we have the reporter. So the collector runs in the background collecting these things, and when you go say, give me a health score or give me details, it'll return the current results that are currently there. It won't trigger a process to go off and running. Allows sufficient tuning of the score based on applications and resources. And this is an area where we would be very happy to work with you if you start playing with this, because we don't run real applications. Each application is going to have its own resource usage and what's good and what's not. So tuning these things is probably something that it's going to take a little time and trial and error, and it's something that we would actually be happy to help you with. If you do start using this, and I put this out on the CVP shortly after 12.0 ship, that my team would be interested in working with anyone trying to tune this for their specific application, because the feedback will be very important to us in improving this service in the future. Allow custom extensions points for customer use. Now, the reason why this is in red is that because this does not make our additional feature list. But I think it's very important. The idea here is that you would have some ABL code that would be its own probe, and that it would be able to determine a health score based on your particular application that would be then combined in with the other probes and come up with an overall health score. Now, in order for us to do this, we need you guys to start implementing this feature and start saying, I need it. Talk with product management, start using it, and we're happy to get it highly prioritized. And then finally, provide data useful for storing, trending, and predictive maintenance. And this is the This is the thing down the road. We're collecting all this data. It would make sense in order to, build up a bunch of data of your application working in real time, and then be able to look at it and see, okay, well, I know that when this resource gets to this point, my customers start getting impacted. So you can tune it, whatnot, and eventually, with data RPM, you never know. There could be a predictive maintenance play in this where an AI actually manages the lifetime of your servers. So primary use case, provide a health score between 0 and 1. So that's what you'll see. Score of 1 is a perfectly healthy server, and a score of 0 is a dead server. So you probably won't even get something back on that. But it'll be something between that. When my server health score drops below specified levels, start up a replacement server and take this one out of service. So our general interface is with load balancers and things like Amazon Electric Load Balancing. You give it a health URL, and what it'll do is it'll ping that on the schedule you want. And it'll either return a 200 saying your server's okay, or a 500. So with our health scanner, what'll happen is once your server goes from healthy to unhealthy, it'll return a 500 there, signaling to the load balancer, okay, something's going wrong here. Now, it doesn't mean that your server is completely malfunctioning. It means it dropped below certain thresholds. So at that time, you may want to start up a new VM and stop sending requests to this VM, and then eventually take it out of service. Now, when you take it out of service, you can also not destroy it completely. So you can go in and forensically analyze based on log files or the current state of that server. So the secondary use case is to provide a mechanism to push health data to a collector that will be responsible for analyzing trending data and eventually predictive maintenance. Now, this is something that we haven't done, but it's something that at the end I'll show you a little tool from from Whitestar that they're starting to look into this and provide sort of this functionality. And I think there's a real use case in order to provide OpenEdge customers with this data. Now, my team itself isn't, we're not UI guys. We don't do UIs. And you'll see the UI that we did during development near the end in the demo. But we had our UX team create this great UI mockup. The problem is, I think the decision was made that it's going to be up to third parties and you guys in order to visualize this. We're providing the API and data. So hopefully, companies like Whitestar and others will take this and run with it. So not a use case, provide health information at a level to take specific action on parts of a server to keep it healthy. Now we do have, this has already been part of PASO for OpenEdge through our JMX interface. You can use tools like Nagios and then ProTop, which I'll be showing later. What they're starting to do with this is you can query these probes or query these beans and do that yourself through another tool. That isn't part of the health scanner. The health scanner utilizes that, but those JMX beans are available to anyone that you, or any technology that you integrate with it. And we're not looking to fix the car at first sign of trouble, we're looking to replace it. So it's like your check engine light comes on, you drive it in the dealer, you drive a new car off the lot. That's the way VMs work. So how does the health service work? Well, we're looking at the whole server health. So we look at, are we running? Are we responding properly? Whether we're getting 200s back or 500s back, or whether it's taking too long, if we're exceeding our service level performance that we want to provide, and performing. And that gets rolled up into a whole server health score. So server running health, are the correct processes running? Tomcat running, or agents running, or connected to your database. Running metrics are binary. Any required process that isn't running gives you a health score of 0, and the way the math works, it'll give you a 0 total health score. Server responding health. So here we're looking at the transports accessible externally. We have these ping URLs, and REST comes with one already installed, and we added them to all the other transports in order to ping a service. And what this does is it'll basically see if you can go all the way through the agent and back. And there's a class in there called OEPing that you can then extend yourself and add some more information, more checks into that if you wanted to. Now, it doesn't make sense to run this on the local machine. It really makes sense to run this outside your load balancer because that's what you're really testing. You want to see that that server is accessible through the app server or through your load balancer to the VM properly. So that's why it would be good if you were going to look at this to set up something outside to do the pings. Track via valve and URL. So the way that we implemented this is that we have a valve there that looks for a ping URL, and it could be for any transport. And when it is executed, it captures its status and response time, and it'll give you a health score of 1 if that status is 200. So server performing health comprised of 2 parts. We have performance, which is the weighted composite metrics, and resources. So basically, we come up with a performing score based on performance minus the resource penalty. So as long as if your system's performing fine, but you're starting to run out of disk space because your log file is growing too large, you'll start getting a resource penalty. Or if your CPU is working harder than the levels you set, you'll get a resource penalty there. So the way that we do this is we have a number of different levels you set. We have a full health level, which is typically 1. Then we have a marginal level. This is where the health scanner will start saying, okay, I see an issue here. It doesn't mean you have to take action now, but something may be coming down the road. And then we have a critical level, where that's where it'll say that it failed. So one of the things, certain things like disk space or CPU, if those start running low on resources, the answer isn't to take out that VM and put in another VM. The answer would be bring up another VM because you're overloading your system. So one of the things that marginal is useful for before you start getting an unhealthy server is, yeah, I'm going to bring up another VM. It'll start taking on load. If my other servers start going back up to healthy, then I know it's just a load issue. And then if your load goes down, you can also scale that way. So that's one of the useful things for marginal, because not every unhealthy server means take it out and replace it. It could be, I need more resources, start up a new VM. And if your server is actually truly unhealthy, starting up that new VM once it got to marginal, it'll be ready to take over once that server goes unhealthy. So we created probes. Now, a probe is what gets pulled internally in PAS-OE and looks at certain JMX beans and other metrics in the OS and Tomcat and Java. So we're looking at, are particular resources becoming constrained, such as memory, disk space, and CPU. Those are the important ones. In Tomcat, we have Java memory and executor threads. Once your Tomcat starts getting up to running low on executor threads, okay, my system's getting real loaded. Maybe I should add some more resources to that. And then on the OpenEdge side, we have our ABL sessions, errors, and response times. So timing probes. Timing probes examines response timings so that you can set a level that all my requests are supposed to take, no more than a second. If you've got small APIs and not running large reports. Once you start approaching that, it'll get marginal, and once you go over that, it'll start becoming unhealthy. Now, because it's only a single probe, that gets rolled up into the whole health score. So unless, we'll talk about this later, whether a probe is marked as critical on fail. But it'll just reduce the health score. It won't necessarily make something unhealthy. But you can also say that, okay, this one is very important. If I start getting to this, fail the health score. Error probes examine error rates. We look at, responses coming back. 200's good, 500's bad. Ping probes examine accessibility from the outside. And again, this would require an external driver to do correctly. You don't want to just do localhost or even on your load balancer because you're not actually testing the full path through. Application probes, again, that's the area that we did not do for this release, but it makes a lot of sense to me that you should be able to write your own custom probes with ABL where you decide the health and roll that up into the total server health score. So looking at the probe types, oops. Okay, so that's a comment. I had somebody review this and they had put comments on it, and I didn't realize they did it as slides. So this slide would have been more interesting with the different probes, but as you see. Probe configuration. So again, we got full health. This is the threshold where the probe starts becoming marginal. Critical health threshold where some action is required. And then weight. Weight is a value between 0 and 1, and that's basically how the math works. Some probes are more important than others, so you would weight them higher. Other probes, you may not want to have in the health score at all, but you want them collecting the data anyways. Those would have a weight of 0. They would still get called. They would still be part of the details of that, but they wouldn't affect the health score. And that determines the overall health of the server. So in the architecture, we built it based on this idea of composite probes. So you have a probe at a lower level, and you could roll them up into different composite probes. And as you'll see from the heat map UI that I'll show in the demo, how they're all broken out into the different sections. And finally, the overall server health score is just one big composite probe with all the other probes rolled up into it. Composite probes have their own weight and threshold. So for instance, like OS resources are their own section. You can rate that higher, even though the individual probes have their own weighting, than say something that's less important. Composite probes rolled up in the whole server health calculation. And the math is the sum of the probes, health times weight, divided by the sum of the probes, weight. So looking at the, Home Depot's got a special. So you're not seeing that. Looking at the VM, this is what the paths for OpenEdge, a basic path server looks like. We got our transports here, session manager. We got our multi-session agents, our agents down there. So when we add in the health scanner, we have a collector piece that gets run in the background on its own thread, and you can set the timing of it, how long or often it'll collect. Then we've got our health service. Again, this is deployed on its own port. It's not going to be affecting any of the transports there, and it's basically calling into to the health server there. So, any questions so far before we start getting into the details of turning this on? Okay. So configuring the health scanner, by default it's turned off. There are two parts of the health scanner. You got to turn on the collector and you got to turn on the service. So the configuration properties here, you've got the collection property here. You just turn that on to true. You can also customize things like set up your config file. Everything done in the health scanner is done in a JSON format. The results we get back are JSON. The configuration is done in JSON. And this is the configuration file where you would set your probes and weights. We have a delay because you don't want the health scanner to start pulling while you're coming up. So you can set a delay there so that it waits for a warm up, or at least your server to be fully come up before it starts failing stuff because things just haven't booted yet. This is just probably Catalina.properties is one of the property files that you can edit through tcman config. The wait interval, we have a wait interval on shutdown so that we can wait for a poll to complete. And finally, or not finally, but then in the interval, how long you're going to be collecting. These are all the defaults here, so every minute we'll run through a collection phase. Timeout, so probes have timeout. You can set an individual timeout. What normally happens is that the timeout, if it's set to -1, we'll just take the number of probes divided by the collection time and come up with the default timeout there, but that can be tuned. And finally, the health check port. This is the port you would come in on to get the results of the health scanner. It's 8899 by default, but it can be anything. So enabling the health scanner. The health scanner is also a feature done through the tcman feature command. If you do a pasman feature there or tcman feature, you'll see that it's in this list. The collector runs independently of the health scanner, so if you don't turn on the service, you can still get to that information through JMX or through JMX. You want to do a tcman feature, And again, that has to be done in conjunction with also setting that property on the previous page. Securing the HealthScanner, you can actually configure the remote address filter, remote host filter to limit what's able to access that. Now, the default HealthScanner URL just returns a blank page with 200 or 500, but you can then look into views and get summary and details of it. So that type of information you may not want to let out to anybody, so securing it through one of these filters is the recommended way. You don't want to have to create accounts or log in or stuff like that for this, but you do want to provide some level of protection. So configuring probes, the property file or the configuration file is in conf oehealth.config. That's probably an I in there. And probes are grouped by parent. Again, the main ones are JVM, Tomcat, our transport probes, OS Health, and then the whole server health. The important settings that you'd be dealing with, and there's a bunch of settings. Each probe has its own additional configuration information based on what it needs to do. It was a wild west there with my developers creating these probes. So the information they return and the way they configure it is less than standard, as I found out from the White Star guys. So important settings enabled, whether the probe is enabled or not. Again, you can have a probe enabled but not have it take part by setting its weight to 0. And then the marginal critical and fail on critical are the other two important properties. Setting the marginal and critical levels will determine whether it's good or bad. The fail on critical is there's some probes that even though you don't want to have to play with the weights in order to get probes to say the server is bad when it is bad based on weight. So certain probes like memory, if you're running low on memory, that may not tip a server into unhealthy if all the other probes are reporting good. But if that fails, you reach that critical level, you want that VM to fail because it's going to fail eventually. So fail on critical, you can set on probes saying, okay, if this probe goes critical, my whole server is going to be unhealthy, and we'll take action that way. So here's a configuration example. As I said, it's straight JSON. This is the actual disk space health probe. Rolls up into an OS Health composite probe, and we have a bunch of JSON fields here. Do it full health is 85%. So if you've got the 85% of your disk space free, you're fully healthy. Extremal health is where is the lower limit. That's normally set to 0, but you could raise it higher to say, okay, yeah, my lower limit is not even at 0. Weight is how much this probe will contribute to all probes in OS Health. Because again, each probe has its own weight, so the OS Health probe has a different weight than this one. Marginal is where it starts going marginal, and what we do is we've added some colors to the return that we use in our HealthScanner. That marginal value is when the color turns from green to blue or whatever we chose for that. And then finally, critical is when it will start being bad. Fail on critical for this is false, even though I think this probably is one that you might want to set to true, but that critical value is kind of high. It's saying, okay, if I have 60% of my disk space free, if I have less than 60%, I'm bad. So accessing the health score, it's done through a simple URL. It's host port /health. And again, it'll return, if you just do this, it'll return 200 if healthy, 500 if not. We also provide summary results. Summary results will return this JSON string. It'll give you the overall health score. In this case, it's 97. The interval that it's polling at, and a timestamp. Now, the timestamp is important because, as I said, we're just returning the last data that was polled. So if for any reason the collector stalls or hangs or whatnot, you'll be polling it and you won't see any difference here. The timestamp will let you know, okay, something's gone wrong. I'm not getting any new data here. So it can be used in order to compare polls. We also have a detailed results view, which I'll be showing, that'll show every single probe that's being done, as well as its details, results, and configuration. And all results are returned as JSON. They're not returned as any standardized JSON that you could load into a temp table, but that actually is a good idea that we may be looking at. So let's take a look at the demo. So the first thing I'm going to show is our heat map. And this is on a development VM that I have back at the office that I use for development. Because it's a development VM, it's highly constrained as far as disk space, CPU, and memory, so it's a good one to show. This is a PASOE instance that basically I just started, but I have not run any requests through it at all. You'll see that the gray here is what it looks like when there's actually been no results to report on. So like for the transport health, the pings are all 0. I'll execute a REST ping here to kick that off. And I will also, in order to constrain my CPU, to show you what that happens, I'm going to just create a new server. Oops. Helps if I spell Pazman right. And this is, what the? Pazman, there we go. Okay. And this is just to create some CPU and stuff. So when we go to the HealthScanner, we're going to start seeing some changes here. So right now I've got a perfectly healthy scanner, or perfectly healthy server at 99%, because I haven't done anything yet. And it may take a minute or so to update this. So while we're waiting for this to update, there we go. So my average request proc time. This demo, okay, this UI here, it ships with the product, but it's not an official UI, so it's only provided as a sample. Now, we created this for ourselves because we needed something easy in order to test it and look at it. We didn't want to be parsing JSON with our eyes. It's not a good way for testing to get a quick result. But so this is what happens. We can see our ping health, that came back as 1. We've got 1 ping there. Each probe itself has its own timestamp, so you can look at it that way. I'm surprised my CPU health did not go down. Normally that that happens quite a bit on this machine. So let's start looking at, so right now my server health score is in the 90s, so it's fine. I'll go to the heat map URL, not the heat map URL, but the health service URL. So if you type in nothing, you'll get that. This used to provide our heat map, but we had to remove it because it's not an official UI. So health, in this case, you'll just get back in a blank page. Because it was a 200, you get no complaints. If the server was unhealthy, it would say 500, and Chrome would say something. Now let's look at our details. So we'll look at view summary. So our current server score is 95, and the timestamp of when it happened was at 15/28/03, which is strange. It must be UTC. Yeah, Z. Okay. So UTC. And then finally, if we go into the details, the gory details, as I'd like to say. And I don't have a JSON parser on this version of Chrome, so this is what it would look like if you didn't parse it out nicely. You can see there's a lot of stuff here. It contains both the configuration as well as the result of the server. And unfortunately, we weren't thinking enough to make this in a format that would be easily accessible by the ABL. We just assumed that people would be using Java to access this information. But that is a good suggestion on that. So now, just go back and check our heat map to see where we're at. Oops. You see we're kind of back up to normal, nothing bad here. So let's look at a few weeks ago, and I really mean just a few weeks ago, we started talking with the White Star guys about Protop, because Protop is, how many people here are familiar with Protop or use Protop? Okay. Well, you can see this in action too at their booth in the expo, but they started looking at it and mocked up a UI. This is actually running live on their server, and Paul Kafalis, who's in the back of the room, can actually show you it in action. They provided some feedback to us, so we need to work out some kinks in this. One of the issues that we had when we developed this, unfortunately, was I could not get anyone on the CVP program to work with us before we shipped it. So there are going to be issues that we're going to be working through. The main use case, though, is at 200 and 500, and we've got that down pat. But these details are stuff we would greatly like to work with you guys and other companies and fix this up so that it's even more useful. So we have our PASOE health here on this server. It's 85.5. Then we got our different health scores there. They're looking at different probes here. These are our probes, and you can click on it and get down to the specific ones and see what they are. We don't know why it's only showing between 0 and 1 here. At that point, that's one of the things that we need to work out. But this is an idea of something that you can do with the data, and eventually, I think Protop will probably be a great UI for our health scanner service. And again, Paul Kafalis, White Star, and they can show you this live at the booth. So with that, I am ready for any questions.
Yeah,
yes.
So it sounds like it's one agent per server. Is that the way it needs to be on the PASOE? Like if you have multiple agents
Right.
on the same server, can you monitor each agent?
Yes. Again, the way that things are broken out on PASOE is you have an ABL application, you have one or more of those, one or more web applications per ABL application, and one more agents between that, and they all roll into one to provide that whole server health.
Okay, so you're at the top level.
Yes.
One of those per server.
Yes. Yes.
What is returned when you run this on Docker? I mean, it's not clear how much resources a Docker container has, so what would you report?
That's a good question.
It wasn't really designed for Docker.
Yeah, it was more, well, I mean, it is useful for Docker in that if you need to take a container out of service because it's going bad, but we haven't tested with that. Edsel Garcia, if you go to his talk on Docker or see him around, he's our Docker expert with PASOE. He may know the answer to that, but we ourselves have not run it on Docker.
Yeah, I wonder how the disk space is used.
Right, yeah. But again, these things are configurable, so there may be ways to tweak it without actually having to change anything for your particular environment. And that's one of the areas that we were highly interested in working with you guys in doing.
You mentioned still the thresholds for performance are still valid, I suppose.
Excuse me?
The thresholds you
Yep.
can enter for how responsive it is
Yep.
still very useful, I suppose.
Yep.
Can you repeat?
Yeah, so the question, yeah. The question is that the thresholds for response time could be very useful because you definitely want to know if your server starts bogging down. You know, it may not be, okay, I need to take this VM out. It may be because, yeah, I'm leaking memory, so now things are starting to slow down. Yeah, there's a lot of probes here, and we're definitely open to ideas for new probes. And if we ever get the ABL probe implemented, then you guys can create your own probes to hook into this, and I think that would be really exciting. Yes?
Are there any plans to, you mentioned memory leaks? That would be great. Probing it.
Oh, yes.
See, it's just not a matter of memory consumption, but how much is leaked?
Right. Well, we do have other, that actually a memory leak probe might actually be an idea. We have this dynamic object tracker built into PASOE so that even in production you could turn it on, see where you're leaking. It might even make sense to make a probe that does that for you. And yeah, so I mean, one of the things that would be great, because we don't have any real live application when real live customers running against this, even if you're deployed on 12, turn it on, but don't use it with the load balancer to determine health, but just collect the data. And you can see, okay, yeah, it says that my server is healthy here, but it looks fine, so I need to tweak this thing. I mean, we'd be happy to work with you guys on tweaking this stuff, because that's what we need in order to make this a great feature.
Did you say that it would automatically spin up another?
No, that's up to the,
Okay.
that's up to the,
I thought I heard that.
right, no, it's,
Well, a lot of people can
Yeah.
confuse with that.
yeah, or you use Chad's task scheduler that he showed last talk and create a task to automatically check it. Yes.
Is there any head
Just screwed all over.
Yeah.
and
They,
there's a project to
yeah,
get it in?
they came up with a great UI mockup. It's just getting it prioritized and implemented by the OE management guys. Last I talked to product management, their position was, well, we provided the data, we provided an API and the data. It's up to our customers to run with it. Yeah.
I need this open.
Oleg Cooperschmidt.
Cooper Schmidt. Don't ask me to spell
That's not a question. He's on the CDP all the time. I'm sorry. If you want to create your own probe, and not an ABL webs.
Right. So the question is, if you want to create your own probe, that would be possible in Java. I mean, we don't document it. It's not supported this time, but it's something that I wouldn't be against, knowing that if you do destabilize the server, there's a limited amount what we can help. We can't debug your probe. But if the server's running 5 without the probe and doesn't with the probe, that's something you're going to have to...
The probe.
Yes, yes. So that's something that may be available in the future. Again, we need to start getting some customer validation on this feature and use of it in order for it to get a higher priority in our backlog.
I mean, it'd be nice to know no one's gonna use it, okay?
Yeah.
We're not gonna put time in the
Yeah.
ABL, we're not gonna put time in this.
Any other questions? Okay, I'd like to thank you all for coming. Let's see.